Hello everyone. Hope you are doing great. Today we will be learning about a very interesting networking device called repeater. What is repeater? Why should we use it? And we will learn about all of its features and different types of repeaters in details. So let's get started. A repeater is a networking device that receives a signal and retransmits it at a higher power so that it can reach further distances than it could have if the signal were transmitted directly from the original source with its initial power. It simply extends the range of a wireless network by copying and forwarding the data signals it receives. They work on the physical layer of the OSI model. The main purpose of using a repeater is to extend the coverage area of a wireless network. A repeater simply amplifies the signal so that it can reach further distances. Now, what is the difference between a hub and a repeater? Both of them are used to extend the range of a network. Then how do we decide which one to use, or when to use a hub and when to use a repeater? Let's understand this with the help of an example. If there is only one network segment and we need to extend its length, then we use a hub because a hub has multiple ports and allows us to connect more devices. But if we need to extend the range of the wireless network, then we use a repeater. Repeaters amplify the signal strength, but they do not allow any device to connect to them. Repeaters are generally used in the following situations: when there are no wired connections available, or when there are too many obstacles and the signal gets weakened. For example, in industrial environments where there are heavy machines and thick walls that can weaken the signal. In such cases, we install repeaters so that the signal can be amplified and can reach to the farthest corner of the building. Repeaters are also used for long-distance applications like point-to-point connections. In such cases, we use high-power outdoor repeaters to transmit signals over long distances. There are many benefits of using repeaters. They are very easy to configure and set up. They are inexpensive. They increase the coverage area of the wireless network. They boost the signal strength and remove dead spots. And they improve the performance of the wireless network. There are some disadvantages of using repeaters too. They simply amplify the signal and do not filter any noise. So if there is noise in the signal, then the repeater will also amplify the noise. If the signal-to-noise ratio gets too low, then it may affect the performance of the network. The other disadvantage of using a repeater is that they increase the chances of collisions. As the signal is being copied and forwarded by multiple repeaters, the chances of collisions increase, and this can slow down the network performance. Another disadvantage is that repeaters are half-duplex in nature. This means that only one device can transmit at a time. Let's now talk about the different types of repeaters. A basic repeater simply boosts the signal without any configuration. They are also known as simple repeaters. These are the most basic type of repeaters. All they do is just boost the signal and forward it. You just need to plug them into a power outlet and they automatically start working. There is nothing to configure. They come with default settings and work automatically. The next type of repeater is a smart repeater. They offer advanced features like better signal quality, better antenna design, and they can handle more traffic compared to a basic repeater. They also support roaming. Let's understand what is roaming with the help of an example. Imagine you are moving around in a mall with your laptop and you are connected to a wireless network through your laptop. Now if you go to the farthest corner of the mall and the signal strength becomes too weak, then the laptop automatically disconnects from the current access point and connects to the nearest access point for a better signal strength. This process is called roaming, and a smart repeater supports this feature. This way you will always have a good and consistent signal strength no matter where you go inside the coverage area. Smart repeaters also have LEDs that indicate the signal strength. This helps you find the best location for installing the repeater so that you can get the maximum signal strength. Some of the smart repeaters also come with additional Ethernet ports. With these ports, you can connect wired devices to the repeater, or you can connect another router in bridge mode to extend the range of the wireless network. There is another type of repeater called dual-band repeater. These repeaters operate on both 2.4 GHz and 5 GHz frequency bands. Most of the modern routers are dual-band, so these repeaters are perfect to extend the range of such routers. They offer greater flexibility and better speeds compared to single-band repeaters. Dual-band repeaters also support the latest Wi-Fi standards like Wi-Fi 5 and Wi-Fi 6. They are perfect for homes and offices that require high-speed and high-capacity wireless networks. Next, we have a range extender. As the name suggests, their main purpose is to extend the range of a wireless network. These are mostly used in homes and offices to eliminate dead spots and extend the coverage area. These days, range extenders are the most popular choice to extend the range of a wireless network. They are easy to use and offer better speeds compared to a basic repeater. Range extenders also support roaming, which makes them a better choice compared to basic repeaters. Another type of repeater is a booster. Unlike a basic repeater, which simply amplifies the signal, a booster also filters out noise from a signal. This results in a better signal-to-noise ratio and improves the overall performance of the wireless network. Boosters are also used in mobile phone towers to amplify the signal and improve the call quality. Last but not the least is a bridge. A bridge is a more advanced version of a repeater. While a repeater just copies and forwards the data frames it receives, a bridge makes a decision on which port the data frame should be forwarded. This is done based on the MAC address of the destination device. Bridges are used to connect two or more networks together, and they can also be used to segment a large network into smaller networks. Bridges are also used to connect to wireless access points to wired networks. Now let's take a look at the internal components of a repeater. A repeater basically consists of two antennas, one for receiving the signal and the other for transmitting it. The signal received by the first antenna is amplified by an amplifier, and then it is transmitted by the second antenna. The amplifier boosts the signal so that it can travel longer distances. A repeater also has a processor that is used to make decisions on which port the signal should be forwarded. A repeater also has memory space that is used to store the MAC addresses of the devices connected to it. Let's take a look at how a repeater works. When a device is connected to the input port of the repeater, a signal is sent to the processor. The processor copies the signal and sends it to the output port. The signal is amplified by the amplifier and transmitted by the antenna. If a device is connected to the output port of the repeater, the signal will be received by the input antenna. After amplification, the signal will be transmitted by the output antenna. Now let's take a look at the repeater in action. Here we have a wireless router and a few devices connected to it, but the signal strength is very weak in the farthest room. To solve this problem, we will install a repeater in the middle room. The repeater will receive the signal from the router, amplify it and retransmit it towards the farthest room. By doing this, we are able to extend the range of the wireless network. I hope you found this video useful. If you like this video, give it a thumbs up and share it with your friends. Subscribe for more updates. Thanks for watching. See you in the next video.